I'm gonna read a bunch of books. Let's see. See, here's my screen. It looks white down here. All right, so let's start today. First thing, I added a new Google Classroom called IM2 second and third period. So after today, or starting today, we'll put your assignments there. And this will help me so that I don't have to go to two different classes to get everybody's assignments. I could just type them in here. And then if you guys have late stuff, don't worry about it. I'll give you full points for anything that's late. You don't want to get too far behind because then it becomes overwhelming. All right, so let's get started. We'll do a quick review and then I'll give you guys the intro of what today is about. All right, so we have some functions. All right, and go ahead and start writing your notes. And I'm looking at my screen. It seems like it takes about a second for it to show up what I write. So I'll keep that in mind. Here's my basic function. Looks like I'm doing the same one as always. All right, and then versus a quadratic. I'm gonna do a quadratic in green. All right, so here's a quadratic. Give you guys a second to catch up. So does anybody know, and go ahead and unmute your microphones, this way we're like more live. What's the vertex for F?
Isn't that a positive 1?
Yeah, it is a positive 1, okay. And positive 1 is the X, and what is the Y? So if you put a 1 here, this all disappears. What's left over?
So it's a negative 3, so it would be the opposite, so it'd be 3.
Well, if this all becomes 0, it would just stay as what?
Negative 3.
Negative 3. There we go. So the Y is just the leftover number outside, and it's not opposite. Make sense? So the X is opposite, right? Opposite. But the Y is same as whatever's out here, okay? All right, so what's the vertex for the quadratic? Same or different? Same, thank you. 1 comma negative 3. Remember, because if you put a 1 here, this is going to turn into 0, and 0 squared is 0, and 0 times 2 is 0. So what's left over? Negative 3, okay? All right, so next, are the steps on a absolute value the same or different? On the purple one, are they going to be the same or are they going to be different?
Different.
Different. All right. Let's pretend we didn't know. Okay. So let's find out. So we know that the vertex is at 1 and the output is negative 3. So you can actually go 2 or 0. What number would you like to plug in and to find out? 2 or 0? It doesn't matter. Just pick one. What's easier, 2 minus 1 or 0 minus 1?
2 minus 1.
2 minus 1 is 0 is actually easier, right? So this becomes 2. So this becomes negative 1. This also becomes negative 1. And let's do another one, 3 or negative 1. So what's easier, 3 minus 1 if you plug it in, or negative 1 minus 1? What's easier? What's easier to plug in, 3? So you have 3 minus 1 or 2 minus 1?
2 -1.
Yeah, 3. Yeah, I'm sorry. I meant 3 minus. Yeah, 3 minus 1 is easier, right? So then you plug it in, right? So there's going to be 2 times 2. 3 minus 1 is 2. And the absolute value of 2 is 2. That's 4. This becomes 1. So the answer is 1. And this answer is 1. So let's find out, are the steps the same size or different size? All right. From -3 to -2, I went down 2. From -1 to, I went up 2. My bad. And it went up 2. So the steps are actually the same size. And what size are they? This is the size of the steps. Okay. So the steps are actually 2. And then you put all same. Now later on, you'll notice that this 2 actually represents that 2 right there. So can you know what the size of the steps is without doing any math? Right? Absolutely. Okay. All right, let's graph this quickly. All right, let me I know it gets a little, I don't know why it's so at the bottom, it seems so so white at the bottom. Okay. All right. The vertex was 1, -3. Let me make this nicer. 1, -3. So 1, -3. 1, 2, 3. 1, 2, 3. And the steps were 2, 1. 2, 1. 2, 1. Same size. And also the same as the other way, right? 2, 1. 2, 1. 2, 1. Same size. All right. This is just a review. It's okay. I actually want to review most days real quick. It kind of helps you more and more. All right, let's graph the quadratic. Let me know if you need me to wait a little bit for the quadratic. All right, the quadratic. Okay. Where's my quadratic? Here it is, green. All right, so the vertex is also the same. Okay. What about those steps? Are they going to be the same size or different size on quadratic? The steps are 1, 3, 5, 7 times what? Times 2, times 2, times 2, times 2. So the first step is actually going to be 2. The second step is going to be 6. The third step is going to be 10. The last step is going to be 14. All right, the vertex was 1, -3. 1, 1, 2, 3. And the first step is 2. So up. I'm going to turn that in. I'm going to make my steps green. And the next step is going to be 6. 1, 2, 3, 4, 5, 6. So I'm going to put a little 2 there. Because if you don't have graph paper, this is how you could do it. Just tell yourself what it's going to be. And the next step is going to be 10. Okay. All right. And then, all right. Make it oval. All right. Did I do a lot of math on this one? What if you forgot about the steps? Well, what you could do is you could make a table and you could just plug in numbers and find out where they're at. Make sense? Plug in the numbers. Okay. All right. So today we're going to talk about a different type of function that is also a quadratic. Okay. But before we do that, any questions on graphing a quadratic that looks like this one right here?
Can you scroll down a little bit?
like this, or like?
I just need to see the other graph because I didn't get it.
Oh, sure, right on. Here we go. Now on the first graph, on the absolute value graph, we actually did the math. We did the actual work, right? But later on, you can do like this if you want. You can say g of x equals a x plus h plus k, and the vertex is the opposite of h comma k, so it's the same as the opposite, and the steps are a value. You can be all the same. So whatever number is here, that's the size of the steps. So if you can understand that, then it makes it easier. But if you don't understand that, you can make a table and just plug in chug, just plug in the inputs and do the math. Okay. All right. So
Mr. Quinones, what do you think is easier, the way you just did or the table?
I think this is way. If you understand it, watch. Let's try this, Olivia. All right. Tell me any number you want. Ready? Go.
5.
5. Absolute value. Give me another number. Negative, positive, doesn't matter.
2.
2. Give me one last number.
4.
4. Okay, watch this. Ready? The vertex is going to be 2, 4. And the steps are going to be 5. So it's going to be up 5 over 1. Up 5 over 1. I'm done with this problem.
That's way easier.
How long?
Okay.
How long did that take?
Like 2 seconds.
2 seconds. Now let's do the quadratic. The same thing. Watch. Oops. Quadratic. It'll be a parentheses, right? And then a squared. All right. Vertex. 2, 4. Right. First step. 5, 1. Second step. 5 times 3, which is 15. 1. Third step. 5 times 5, which is 25. Done. But notice how the quadratics are like smooth, right? And these are all the same. So this is kind of where I'm trying to get you guys to get to, where you can just see it and analyze it and know what's what, right?
Right.
Quadratics, you're going to multiply 1, 3, 5, 7, 9. You're going to multiply these steps by 5 because the steps got bigger. But in absolute value, the steps are 5, 5, 5, 5. The steps don't change. Well, you're multiplying it by 1, I guess, but that's boring. Okay. All right. And I appreciate that question because I don't want you to think like I think, but I do want you to use some of the years of experience that I have so that you're not making a table and, it's the same thing, right? Same thing's going to happen. Okay. All right. Let's do today's intro. Okay. So here is today's intro. All right. So this, right, intro, and I call it intro because it's going to take us a while, is the same as this. You guys agree with that? And this is this is called standard. This is the basic way, right? We say it. And this is this has a name too. It's called factored. And factored means it's broken apart. Broken apart. For example, 18 is the same as 9 times 2. See, it's broken what? Broken apart. 18 is also the same as 3 times 3 times 3 because we broke apart the 9, right? Now, when you break it apart, you're breaking it apart with multiplication, right? Not by addition. Because 18 is the same as 17 plus 1, but that's not a factor. Factor is when you break it apart with multiplication. So let's see if you guys can help me out with this one.
3 times 3 times 3 is not the same as 18.
Yeah, my mistake. Thank you. No, good catch. Thank you. I meant to drop down to 2, right? Good catch. Can somebody break apart 54? What is 54 the same as? Come on, guys, let's go. What's 54 the same as when you multiply?
8 times 6.75.
Oh, yeah, good catch. Do them with whole numbers. Like, yeah, otherwise we're going to have unlimited answers, right?
9 times 6.
9 times 6, good. 9 times 6. All right, continue breaking apart 9. So what's 9 the same as?
3 times 3.
3 times 3. And also break up 6.
3 times 2.
3 times 2.
Mr. Quiñones, can you scroll up a little bit, please?
Like right there? Right,
yes.
Give me, yeah. All right. So when you break apart 54, you are factoring it. You are factoring it. And what are these numbers called? They're called factors. Now, as a kid, this would blow my brain that everything's called factor. I'm factoring something, and when I'm done with it, I'm calling them factors. So every once in a while, I'm going to tell, oh, you need to factor this. And what you got to hear is, oh, I need to break it apart. And then I'll say, what are the factors? And then like, oh, they're the things that got broken apart by factoring. Okay. So far, so good. You know, I'm going to go into the hard stuff because this is like the simple stuff. So let's factor this. And I did it in the top. So what is the same thing as saying x squared?
X times x.
X times x. What about this one?
X times x times x.
X times x times x. What about this one? And I think I went up a really high level. Like, what? Like
X times x plus 6, x plus 9.
good try. It's actually this.
I'm guessing here.
Yeah, it's actually this. And you're like, what? How does this turn into that? Does that make sense? Or vice versa, right? Because they're equal, right? All right, so I'm going to show you guys. This is what today's lesson is right here. It's like how, and I actually went up really fast. Let me give you one before this one. How about this one? This one's a little easier. What times what gives you that same answer right there? Ready? It's going to be this. So, you know how you distribute? What if you put the 5 back in here? What will it give you? What if you multiply the 5 times the 1? What would it give you? So, the idea here is that and it's going to take time. It's going to take maybe like a week of us to practice. How do you turn this into this, and more importantly, why would you even bother, right? Make sense? All right, so here is how I'm going to introduce this lesson. I'm going to come up with a function, a quadratic. Let's go. There we go. Okay. Now, notice this does not look like this. It's not the same, right? So far, this is what you know, right? This is what we kind of know so far, right? For the one that we know, what is the vertex of this one?
-3, 0.
-3, 0. Really easy, right? What are the steps? Notice there's a 1 out here. What are the steps? 1, 3, 5, 7, and so forth, right? Easy, right? Simple. But this one's different. We can't find the vertex for this one. Does that make sense? In order to have the vertex, we need to have that squared here. We need to have this piece right here. Because if you put a 3 here, it won't work. So let's make a table, okay? And we're going to make a table. There we go. All right, guys. I'll take your educated guesses. What would be a good number to input for x that it will be easy to do the math? What would be a good number to start with?
4.
4. Okay. Let's put a 4. Okay. I'm going to put 4. So I'm going to replace all the x's with 4. All right. So what's 4 plus 3? 7. And what's 4 minus 1? 3. So what do we do with 7 and 3? What do the parentheses mean to do? Multiply. So it's 21. All right. So we got one answer. We got 4, 21. All right. All right, guys. What is another input that would be kind of cool to plug in?
3.
3. Let's do 3. Okay. 3. So I'm going to replace all of the x's with 3. All right. 3 plus 3 is 6. 3 minus 1 is 2. So that we're going to multiply this and be 12. Okay. By the way, this looked like it went up by what's 21 minus 12? 21 minus 12. Is that 9? 8 to 20, right? It's 9. I think we're right here. All right. What do you think the next one's going to be? I don't know. Let's plug in 2, right? We're going to plug in 2. So we're replacing all of the x's with 2. Remember, we're doing an exploration. You know, later on, I'm going to show you how to not even do any of this math, right? All right, 2 plus 3 is 5. And 2 minus 1 is 1.
It's 5.
So that's 5. So how much did it go up from 5 to 12? How much did it increase?
7.
7. Hey, it follows this pattern over here. Right here. What do you think the next one's going to be? Probably
5.
5. I think it's going to be 5. Let's pretend that we're guessing. So what number plus 5 is 5?
10.
I asked it kind of in a weird way. What number plus 5 is 5?
0.
0. Yep. All right. So we're gonna plug in which number? We're gonna plug in 1. Okay. All right. We're gonna replace all the x's with 1. Notice I'm trying to put the x's in red. By the way, you can see a pattern: 7, 6, 5. What do you think this is gonna be? Look, 7, 6, 5, 4. Let's follow the pattern. 3, 2, 1. What do you think the next number is going to be? 0. So what number times 4 is 0? 0. Excuse me. I meant to say 4 times what is 0? All right. So this is a really important number right here. And let me tell you why in a second. Let me just put all the coordinates. 3 comma 12, 2 comma 5, 1 comma 0. What is this called? This point, is it called y-intercept or x-intercept?
Y-intercept.
Let's see. Let's find out. We're gonna graph it. We're gonna see right now. Okay. So let's make a little table. A little graph over here. Okay. All right. And I'm gonna plot these points. 421 is too hard to graph. It's too high up. It's too high. 312 is probably doable. 1, 2, 3, and then 12. 5, 10, 11, 12. So 312. And then the other one's 2, 5, 2, 5. And then the other one is 1, 0. So does 1, 0 cross the x-axis or does it cross the y-axis? 1, 0. So is 1, 0 on the x-axis or is it on the y-axis? What do you guys think?
X-axis.
X-axis, yep. So this is called the x-intercept. Okay. All right. Now let's keep going. What's below 1? 0, right? Remember the pattern? 7, 6, 5, 4. What do you think the next number is going to be? 3. Let's follow the pattern. 0 plus 3 times 0 minus 1. So what is 0 plus 3? 3. And what is 0 minus 1? Negative 1. So what's the output? What is the y? 3 times negative 1. Be negative 3. So this is going to be 0, negative 3. So this is the y-intercept. Y-intercept. All right, here we go. All right, so we're gonna keep going, and then hopefully you guys can see a pattern, and you're like, oh, this is gonna save us a lot of math. All right, what's the next x we got to plug in? -1. Oh, by the way, how much did it go up from -3 to 0? Plus 3. All right. What do you think the one right before it was? Okay. All right, so we're going to plug in -1 for x, -1, -1. So -1 plus 3. So 3 minus 1 is 2. And -1 minus 1 is -2. So this is -4. So this went up plus 1. So if these were steps on a ladder, do you think that the next step is going to be our vertex, our lowest point? So 1, -4 is right here. All right, so let's go one more, -2. So if you plug in -2, -2 plus 3, -2 minus 1, this is going to be 3 minus 1, 2 is 1. This will be -3. -1, -4, -2, -3. So it looks like I got my vertex right here. Vertex. Let me scroll it up because I can see that it takes a few, like maybe like 2 seconds from when I write it to when you guys can see it. So I apologize for that. By the way, how do I know that's my vertex?
Are we gonna go over this again?
Of course, this is just an intro, right?
Okay.
Yeah, but yeah, look at the dots. Which is the lowest dot?
The vertex.
The vertex, yeah. I can see my dots. So like, whoa, it went down and then now it started to go up. Now, shouldn't I stop using math and start using my pattern? Remember the steps? Up 1 over 1. What's the next one? What's the next size of step? 3, right? 3 over 1, okay? Now, my graph is a little funky because I got... so let me just do one more math, and then you're going to see... I'll introduce to you why you want it in vertex form. I mean, factored form. So I'm going to plug in -3. All right, so 3 minus 3 is 0. And what's 0 times anything? 0. I got my other x-intercept. All right, now watch this. Let me wait till that's open. Now look at these two very important points, this one and this one. Now look at the original function and tell me that you don't see those numbers there, but opposite. So my x-intercept is -3. Do you see -3 inside of the function in the equation? Do you see the -3, or is there not a -3, or is there the opposite of -3?
Opposite of -3.
Opposite of -3, right? Now the other x-intercept is +1. Do you see a +1 or the opposite of +1?
Wait, where? I see
Oh.
positive 1 in the x-intercept.
Yeah, in the function, right? Here is the other x-intercept, 1. Do you see the opposite of 1 inside the equation?
Yes.
Yes. So the x-intercepts are the opposites. See? The opposite of this number, the opposite of -1 is 1. So 1 minus 1 is 0. And what's the opposite of 3? Right? -3. So those are the two x-intercepts. Okay. I know this was kind of I threw a lot at you here, but I want you to start seeing that this is unnecessary. All of this will be what? Will be unnecessary later on. Okay. All right. Let me introduce you why that works, and then I'll do a little bit of Khan Academy with you guys, and then we'll get that going. Okay. All right. Ask questions though before I move the screen. Remember, this function doesn't give you the vertex. It gave you the x-intercepts. It gave you the x-intercepts. This one gave us the vertex just by looking at it. Okay. All right. Let me look at. Let's do one of these. Ready? Okay. H of x is x plus 4, x minus 2. All right. What is your first guess of what one of the x-intercepts? Remember, they were the opposite. Which one? -4. Exactly. Yeah, -4 will blow everything up and turn into 0. And what's the other one? I thought I heard it, but I didn't. What's the other one?
+2?
+2 will give you a 0 as an answer. That's how simple it is. By the way, why does it give you a 0 as an answer? Well, let's plug it in. 2 plus 4 times 2 minus 2. I plugged in 2 to both x's, right? So what's 2 plus 4? 6. What's 2 minus 2? 0. What does this 0 do to that 6? It turns it into what? A 0. So that's how you get this one. How about the -4? How come the -4 is an x-intercept? Well, plug in -4 to both x's. All right. 4 minus 4 is 0. What is 0 times who cares? What is 0 times anything? 0. Do you see why I said who cares? Because it doesn't matter what the answer is. It's going to become 0 once 0 multiplies to it. Okay. So if you were graphing this equation, you would have the x-intercepts. One of them is going to be at -4, and the other one's going to be at 2. So gives x-intercepts. Now, the vertex is in the middle of the two numbers. Now, what number is smack in the middle of -4 and 2? What number smack in the middle? By the way, how far apart is -4 from 2? Let's see. 1, 2,
+6.
6. Yeah, it looks like I didn't do my graph very well. Let me do this again. It is positive 6, right? So what if you cut 6 in half? What do you get? 3, right? So they're 3 apart. So 1, 2, 1, 2, 3, 4. So 1, 2, 3, 1, 2, 3. So the vertex is at 3. I'm sorry, not at 3. At 3 from there is negative 1, right? All right, so this is the x of the vertex. What do we got to do with inputs? We have to input them. All right. So all of the x's become negative 1. I forgot what the function was. Plus 4? All right, 4 minus 1 is 3, and this is negative 3. So what's 3 times negative 3? And this is the y. All right, so it's negative 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right down here. Vertex. It's negative 1 comma negative 9. Okay. Now, we kind of know the steps from there are up 1 over 1, up 3, 1, 2, 3 over 1, up 1, 2, 3, 4, 5. So there's our equation right here. So how much work did I have to do to graph this one? Did I have to do a lot of work, or just find the x-intercepts, find the middle? I only plugged one number in. Okay. All right. So this is just an intro. It'll take time to practice. Okay. This just wanted to show you like where this is going. Okay. But look how much work the first one was. Let me look how much work the first one was, and look how much work the second one was. Which one had more work? The plugging in every single number, or understanding that the x-intercepts are easy if they're given to us? All right, so let me take you to Khan Academy, and I'm going to show you how it's going to look. Okay, so we do this one. Okay. All right. This is in factored form. What number can you put in x to make negative 4 become 0? So what number can you put here to make negative 4 disappear? I mean, sorry.
Positive 4?
Yeah, I'm sorry. I meant, yeah. I actually meant to say positive 4, but my brain was giving the answer. So it is actually, it's negative 4, right? The opposite. Make sense? All right. What number what number can you put in x to get rid of negative 1? And on this one, positive 1, except that we're going to double it, right? So that means we have to actually half it. So I'm going to do this one on the screen over here. So it was this real quick. We had 2x minus 1 times x plus 4, right? So either x is negative 4, that'll work, right? Because negative 4 will turn into that, and it'll turn into 0. Or this whole thing is 0. So we add 1.
This is a lot of information to process.
That's okay. All right. And then x equals half. So the two answers are negative 4 and half. So which one is smaller, -4 or half? Okay, so you got to put the smaller one where it says smaller. Okay, let me do another one together. Okay, then I'll post it and I'll stay with you guys while you do this one. Okay, let me go to, I need to press practice again. Hang on one second. For some reason, whenever I'm on the screen, it doesn't allow me to press the, here we go. All right, so this is easy, right? 3, right? This one's different, 2x minus 8. So on that one, you actually want to do it like this. 2x minus 8 equals 0, and then just add 8. So you're going to have 2 times something equals 8. X is 4. So that's the other answer. So who's smaller, 4 or 3? So you got to put the small one and the larger one in the right spot, okay? If you have 2 answers, that's fine, but you got to put them in the right spot, okay? Okay, I'm going to do one last one, then I'll assign it. All right, Amar, which is the easy one to get the 0? This one or this one?
Can you repeat the question, please?
Yeah, so yeah, which x will cancel out -4? What number will make -4?
Positive 4.
Positive 4. So we know 4 is going to be an answer, right? Now this was harder. You gotta write that up separately on the side. -5 plus 1. So that one you gotta do it. You gotta do -5 plus 1 equals 0. So you're gonna subtract 1, right? Then you have to divide by -5, -5. So x equals 1/5. So that means 1/5 is smaller than 4. And that's going to give me, okay. So last one, and then you guys can do it. This is super easy. Can somebody tell me what number is going to be in here? I wish I had like a highlighter so you guys can see where my mouse is really easy. I'll figure that out. What number can I put in here to make -2 disappear? Anybody? What number can I put into x that'll make -2 become 0? Two. Okay, so 2's there. And what number can I put in here to make +3 disappear? -3. Careful, because -3 times 3 is 9, right? -9. So it's actually a third of your answer, right?
So it'd be 1/3.
One. Yeah, so it'd be, let's see, it'd be 9. 9 divided by 3 is -1. Now, the way you should do this is you should write this out, 3x plus 3, and you just write it 3x plus 3 and say equals 0. So you know the answer is equals 0, so it means subtract 3, right? Now, I could do this without doing this work, but you guys are barely learning it. So what's the real answer? -1, right? So perfect, -1, okay? And then I'm going to press that. All right, so I'm going to assign this to you guys, and then I'll stay with you as you do it, okay? When you graph it, the graphing, we're going to just introduce it for today. We're not going to finish it today. So the x-intercepts are going to be -1 and -7. So -1 and -7 right there. But look, you see this function? All of the x-intercepts are the same. So we're not going to get to this until tomorrow, right? Because I want you to know, like, wait a minute, which vertex is it? They're all going to have -1 and -7, right? But you know, you're going to have to plug in -4 inside of x, and that'll tell you where the y is, okay? So I'm going to plug in -4 here, and then do the math with a calculator, and it'll tell me where to put this dot. It's going to be up here, it's going to be down there, okay? But for sure, it's at -7 and -1, okay? So let me give you guys the zero product first, and I'll stay with you as you're doing that, okay? So everybody go ahead and go in Khan Academy and try to get 4 in a row, okay? It's assigning right now. Try it out. I'll stay with you and help you out as you're doing it. And you could actually project it, or you could tell me the one, you know. All right, go ahead and go, and I'll wait here. Oh, here's the thing. There's a writing tool I wanted to do here. There we go. So while you guys are doing this, I'm going to do this one on the screen, on the same screen. Go ahead and everybody go in Khan Academy. It's called Zero Product Property. If you put on your
Are all of these due tomorrow?
only the zero product property. They're all due Sunday, right? But you wanna get them all.
They all say due tomorrow.
Okay, I'll fix that. Thank you for letting me know. Okay. How many are there? Is there 3 or 1 or what? Okay.
There's 4.
Okay. Let me fix that. So for today only, do zero product property. Okay. Tomorrow we'll do the graphing one. But I do want you guys to do the zero product. It might take you a few seconds. It might take you a couple minutes, but we'll just do it nice and slow here. So for example, on mine, it's going to be -6. And then this one's going to be +1. So -6 is smaller. And you might accidentally put them backwards. And then you'll just have to learn to be careful. All right, so while you guys are doing that, like I said, I'm here. If you get stuck with one, or before you press enter, let me know what it is, and I'll give you some feedback. You can tell me what the 2 factors are. The factors are the stuff inside the parentheses. I think the zeros is I tapped it twice. In the graphing, I tapped it twice. There we go. And I'm here. If you guys need any help, let me know. Oh, should I assign this differently? Hmm. And you could look at the graphing one too, if you can just kind of do one or two of those, and then we'll do those tomorrow together. Remember, when there's a number in front of x, that's going to change the number a little bit. It'll have the opposite effect. If
I have a question.
Yeah, let's get. What do you got?
So for one of these, it says write the smallest solution
Right.
first and the larger solution second.
All right. What are the factors? X plus and x.
So x plus 6 and then negative x plus 1 equals 0.
Okay. So what's the easy one? Which number goes here?
X plus 6.
Yeah. So what x cancels out positive 6?
Negative 6.
Good. So what number can you slide in here to make this become negative 1?
1.
1.
I mean,
yeah, 1.
Yeah.
Exactly. 1. Because it's already negative, so you don't want to change the sign. So which one is smaller, negative 6 or 1?
1, negative 6
So
is smaller.
Yeah, so that's the first number you put in. The second one you're going to put is 1.
Okay.
And when if you were to graph this, those are your x-intercepts, right? Negative 6 and then positive 1. And then your graph will look like that probably. But right now we're not graphing, we're just finding the x-intercepts. So if you put it backwards, it wouldn't accept it. Now, I think they should just take them which way. It doesn't matter, but I guess it's just the way it can grade it, I guess. All right. Anybody have any other ones I can help you with? All right. Let me just do that. I'm going to fix this. And don't forget that I'm going to be putting this on the new Google Classroom, number 10. Try to get 3 in a row correct. If you can get the 4th one in a row, that's great. If not, we can get it later. Yeah, I can improve your scores over time. And just to recap, the reason why we're doing this is because when the function looks like this, then it's going to be easy to graph because it's giving us the x-intercepts rather easily. Okay, but right now you're just finding the x-intercepts fast. Let's see. Okay. So when you're done, you can just sign off, say goodbye, so I can know that you're going. And also, I did post the assignment 10 on the new Google Classroom. And you can just take a picture of your notes, and then I'll get your scores for Khan Academy.
All right, bye, Mr. Quinones.
Bye, thank you. Were you able to get those pretty easily?
Yeah, I'm still working on them, but I think I got it.
Yeah, don't worry. Remember, the ones that have like an extra number on the outside of the X, just take it out and put equals 0 and then solve it like in 7th grade. Right?
Thank you.
You're welcome. Thank you. Good luck.
Bye, Mr. Quinones.
Bye, Van.
Bye, Dennis.
Thank you, everybody. Bye.
Bye, Mr. Quinones.
All right, guys. I appreciate that. I'll post this for later on for other people. All right. Hey, gentlemen, if you're... bye, Ricky. Thank you. Thanks for joining. I'll stay here with you guys while just to make sure that you guys are supported and you understand. If you get stuck with one, I'm right here. Or Hayden, the larger x is the value, like whichever one's bigger, right? Sorry, I didn't see your text earlier. But if it's negative, the bigger the negative, the smaller the number. Like -5 and 1, or -5 would be smaller. Okay, so like the value, right? On the number line, the value is the smaller one, whichever one is the smallest, the most on the left of the number line.